Okay, good morning, afternoon, or evening, everybody. Welcome to the NASA Commercial Satellite Data Acquisition Program Vendor Focus ICEYE US webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Saving Time, so I'm going to kick us off today with some information and a few logistics. To ensure the best audio experience, all participants have been placed in silent mode. But if you have any issues or you have any questions, please enter them into the Q&A panel rather than the chat, and you'll find that located on the right side of your screen. If you do not see the Q&A panel, click on the three dots at the bottom of your screen to pull up your panel options. You can then add the Q&A panel by inserting a check mark next to the Q&A option. Just a quick word about the chat. Participants will have the capability to chat with the hosts and all of the presenters, but not with other participants. So if you have any questions, please enter them into the Q&A panel on the right side of your screen. Today's webinar is being recorded. The recording will be posted to the CSDA program playlist of our NASA Earth Data YouTube channel within a week of completion. Once completed, what I will do is I'll send an email to all registrants and participants that includes links to both the recording and presentation slide decks used within today's webinar. As far as timing is concerned, today's webinar will be 1 hour long with 45 to 50 minutes allocated to the presentation and live demonstrations. A 15-minute Q&A period will follow, and depending on the volume of questions we receive, we may extend the Q&A session, but we will have a hard cutoff of 3:15 p.m. Eastern Time. All right, let me now advance to the next slide here. Okay, during this afternoon's webinar, we will have one speaker from NASA's Commercial Satellite Data Acquisition Program and 3 speakers from ICEYE US to present the vendor content. Dana Ostrenga will be our first speaker this afternoon. She is the NASA CSDA project manager here at Goddard Space Flight Center, and she'll kick us off with an introduction to the CSDA mission and program goals and a brief overview of the NASA CSDA ICEYE US contract and data access. From there, we will transition to our ICEYE US vendor speakers. Our first speaker this afternoon is Alexandra Gloria. Alexandra is a program manager at ICEYE US. She is going to kick us off with a brief overview of ICEYE US, its constellation and missions. From there, we will transition to our second vendor speaker, Alva Bickner. Alva is a product manager and will continue the presentation by speaking to ICEYE observation capabilities. Once Alva has finished with his portion of the presentation, we will transition to our third vendor speaker, Dr. Tom Mitchell, who is a synthetic aperture radar or SAR scientist at ICEYE US. He's going to provide a comprehensive overview of the SAR expanded capabilities and observations, and then once finished, we'll toss it back over to Alexandra for an overview of how to access ICEYE data. All right, and then once this presentation piece is completed, we're going to move to the final optional polls, and we'll open up the question and answer session. For this afternoon's Q&A session, we will also have an additional panelist, Kyle Gray, who is a SAR engineer at ICEYE, join us. All right, before I toss it over to Dana, I'd like to say just a couple of words about this afternoon's Q&A session. We will try to address and answer all of the questions within the time allotted, but if we are not able to address, excuse me, your question during the Q&A period, our speakers will be able to follow up with you offline. All right, so with that, it is my pleasure to introduce today's first speaker, Dana Ostrenga. And so at this point, I'm going to stop sharing my screen, and I'm going to give the presenter role to you. Yes.
Great. Thank you, Jennifer, for kicking us off. Welcome, everyone. So once again, we are here to learn a little bit more about ICEYE, our partner with the Commercial Satellite Data Acquisition Program. My name is Dana Ostrenga, and I am the CSDA project manager out at Goddard Space Flight Center. So why does NASA buy and have an interest in commercial satellite data? As you probably already aware, NASA has a very large fleet and funded projects that provide a suite of data that covers a large breadth of solving complex the complex Earth system, looking at observations and helping to support science and application goals. In To help augment that large fleet and suite of data, commercial data can play an important role to that data suite by providing more high-resolution data with more frequent observations and complementary measurements to the ones that are already taken by the NASA fleet. So why does NASA help the commercial space sector? We do the evaluation of the commercial data when they come on contract and they become our trusted data providers, and we start working on integration into our science and applications. We also have a broad expertise and experts or in observations, and instrumentation and calibration that can help feed back to the commercial space sector. And we also provide that critical revenue stream of purchasing that data and making it part of our full suite. So to talk a little bit more about the CSDA program, in case you've missed any of our previous webinars, just to give a little background, the Commercial Satellite Data Acquisition Program has the mission to focus on identifying, evaluating, and acquiring commercial satellite data that supports that science, research, and application goals I mentioned. The program has 5 main goals. One is to establish that continuous and repeatable process to on-ramp new commercial data vendors. 2 is to enable sustained use of that data for a broader dissemination to our scientific community, to ensure the long-term data preservation, access, and distribution of that data, ensuring scientific reproducibility, to collaborate and partner with interagency and international partners on the evaluation and scientific use of that commercial data, and then to comply with the 2003 US Commercial Remote Sensing Policy. And if you've missed any of our previous webinars, there's a link that's in this slide deck to bring you to that YouTube channel. It gives you the playlist. So we completed last year, end of last year, our IDIQ on-ramp 1 back in September. This was a multiple award of an indefinite delivery, indefinite quantity fixed price contract. It was in response to an RFP, and that closed March of 2024. The contract goes through November 2028, and we awarded 8 new vendors on that on-ramp, which brings our total vendors in our IDIQ contracts to 15. We will hope to keep growing this suite of vendors, because you can see here from this chart, we have a lot of representation across the sensor capabilities. So we have multispectral, hyperspectral, precipitation, radar, SAR, GNSS, and more. And we also share with some of our interagency partners some of the data capabilities that some of these vendors provide. So this is really starting to grow into a nice suite of complementary data to the full NASA data suite. We have 2 types of contract vehicles. Right now, we have moved into one primary, which is the IDIQ, and we've closed out the previously blanket purchase agreements that some of our contracts were under. We've been building upon our collaborations with federal partners as well as international partners, as I mentioned, when it comes to data assessments, new capabilities, and data sharing. We continue to work to create a more efficient search and discovery of our data by offering our authorized users the search capability through the NASA Earth Data Search Client, as well as our Satellite Data Explorer. Our program is also heavily focused on the continued assessment of the quality and utility of the data. So we're really looking at our vendors listed here as we go through this evaluation process. You can kind of see the data that's been available as part of our program originally through the pilot stages, the DSIS and EarthM data from PGC. We have data that we've been acquiring from Planet, Spire, and Maxar. We have evaluated data previously and are now starting to make it available through GeoOptics, GHC, Capella, Black Sky, and Airbus. And we have current evaluations underway with Maxar, Planet IQ, Umbra, Satellogic, Tomorrow.io, and Pixel. And then we've continued to purchase data as we find and determine needs through the NASA programs from a lot of these vendors once they go into sustainment. So today we're here to talk about ICEYE and learn about the suite of SAR data that they have available. ICEYE has been part of our program since September 2022, when they were previously awarded a blanket purchase agreement to acquire and evaluate that SAR data. 2 types of evaluations took place at that time: a quality evaluation from a team of subject matter experts, and a utility evaluation was conducted by a group of selected PIs through a proposal process. In September 2024, ICEYE entered into an IDIQ contract, and because they've been briefed on the results of their evaluations by those two teams, they are able to provide data through competitive task orders now. The data that is acquired from the task orders and during the evaluation will be available to the authorized users. We're making that available through a process right now through the Satellite Data Explorer and then the Earth Data Search client. You can get authorization through the CSDA web form listed here. And you can also here see a screenshot and a link of our Satellite Data Explorer where you can search and access the data as an approved user. So data that is downloaded will continue to be integrated and available through this interface and through the EDC, as I mentioned, just to make our data more accessible across not only to our authorized users and across the whole suite of the Earth observation data. So that brings us to our next portion of our webinar. Please welcome again our invited speakers who will talk to you about ICEYE. So I'll stop presenting, and Alexandra, you can take it away.
So thanks Dana for introducing us. As mentioned, I'll be starting us off with our ICEYE overview and then kicking it over to Alva and to Tom. Okay. Can y'all see the agenda now?
I can just see your title slide. There we go. Perfect.
There we go. Okay, so I'll be taking you over through the overview, and then I'll turn it over capabilities, and then we'll talk about our SAR expanded, and then I'll close this out by talking about how to access our ICEYE data. I wanted to just show you really a new way to really think about how to solve a lot of our big problems by utilizing radar satellite imagery. We're hoping with this delivering, it's making sure that it's reliable, it's going to be near real time, and able to support decision makers in all lot of different ways, different problems that they're trying to solve. So our ICEYE satellites are really different from traditional satellites that you may be familiar with. Ours are smaller, they're more cost effective, and they're very flexible. So what that means is that we're able to really collect for a much more extended time, and that allows us to also really utilize that radar beam to access a wider area. And this results in more modes and meaning better means for collection efforts, as well as a wider range to look over. So if you didn't know, we are the largest commercial SAR satellite constellation. Our first one was launched in 2018, and then by 2019, we had already had 5 launched, and then we closed out 2024 with 40 satellites. So ICEYE, we have a proven track record of having multiple launches successfully put up into the sky. We started off, as I mentioned, so with 2 in 2018, but now we are at 48 as of March of 2025. So how do we get there? So 2018 with 2, then we had another additional more in 2019, bringing us to 5 total. We had our most in 2023 with 10 being launched. And then last year we closed at 2024 with 40 total being launched. And now we're on track to launch an additional 20 this year. So if you're interested in climate research, disaster response, perhaps it's even resource management or maritime awareness, ICEYE is going to be able to really support those decision makers. We're able to, with that persistent coverage, really just help scientists, economists, as well as security advisors solve their problems. So who makes up the US team here at ICEYE? So while we are based in Irvine, California, our team actually works across the nation. So Alva and myself both work in the DC area, and then Tom joins us from St. Louis. At our headquarters in Irvine, California, that is where we actually build our satellites. They're at our headquarters there with our team, as well as our satellite ops. So our customer planning is also operated from there at our headquarters. So that's our quick, big rundown of ICEYE US and everything that makes up our team here. And now we turn it over to Alva to go more into our capabilities.
Thanks, Alexandra. As Alexandra said, I'm going to be walking through some of the capabilities and products that we offer at ICEYE US. ICEYE's expanding capabilities really use as a backbone our generation of satellites. We're constantly working to improve these generations and launching more and more advanced satellites every single year. Where we really try to focus on 3 areas, and that's improved coverage with coherence. We do that with wider angles and better imaging parameters. Rapid access to the data using quick downlinks and API-driven interfaces, and world-leading resolution with reduced noise levels, with the double width of our antenna and 3 times the bandwidth. So as you can see listed in the bottom here, we talk about our 3 generations of satellites that we're working with today. Our generation 3 is the workhorse of our fleet right now, with 17 Gen 3 satellites launched to date. These have 600 megahertz bandwidth and 500 megabits per second downlink speed, with a phased array of 1.3 meters squared. Our generation 3.5 is similar to our generation 3, and we've launched 10 to date, except this boasts a 1200 megahertz bandwidth capability. We still have a 500 megabits per second downlink and a phased array of 1.3 meters squared. That 1200 megahertz bandwidth allows us to image 25 centimeters. 600 megahertz is 50 centimeters. Generation 3.5 is kind of a stepping stone to Generation 4, which we view as the future of the ICEYE fleet. We launched this first demonstrator in March of 2025, and this has also a 1200 megahertz bandwidth with the same downlink speeds, but this utilizes a double wide phased array at 2.6 meters squared. This does a couple things and enhances a couple different areas, but one of the largest is that we can now have larger incidence angle accesses. So instead of imaging from 20 to 40, we can go larger in that respect. And it also decreases the signal to noise ratio when we image. So we can now get 25 centimeters with our Gen 3.5s and Generation 4, but the Generation 4, even though it's using the same amount of bandwidth, will just have less signal to noise ratio. So these 3 generations really allow us to expand our capabilities and meet mission needs across the spectrum. Go ahead, Alexandra. So we're going to touch really quickly on the phased array, which is a unique capability to ICEYE as opposed to a parabolic array, which many of the providers use. Our phased array is fully populated elevation. What that means is that we have extremely good precision on steering the beam instantaneously. This allows us to do a couple different things, but 2 of the ones that I'm going to focus on here today are wide area collection and multi-image acquisition, or MIA for short. Wide area collection is something that our phased array really allows us to branch into and provide a unique capability. We can provide a scan mode of 100 kilometer by 100 kilometers and 30 kilometers by 50 kilometers of a strip mode, both at 12 meter resolution and 3 meter resolution, respectively. The phased array allows us to do this because it allows us to change the direction of that beam using beam steering and not mechanical steering almost instantaneously, as I mentioned, meaning that we can take large swaths as we're passing over one area. That also allows us to do something called multi-image acquisition. So instead of being able to get one image over a pass, what we can instead do is steer that beam instantaneously in multiple different directions with incredible precision. This allows us to collect multiple images in a pass. As you can see, the 2 photos on the right up there, we have the photo on the right, which was taken over Australia. We were able to collect 21 50 centimeter images in a single pass at one look. And the image on the left there is 6 2-look images, all collected within the same pass, also at 50 centimeters. We're working to continuously expand this capability, and obviously with our Generation 4 satellites, we're going to be able to continue to improve the numbers that we can get. But what this really does is it allows us to increase our capacity so that many end users or single end users can get as many images and as much coverage as they can, mixing and matching modes, mixing and matching their variety of imagery that they need to better complete their mission. Go ahead, Alexandra. So we'll spend a little time now talking about what we can do with our modes. The generations in the phased array that I described allow us to do a vast variety of imaging modes. So the top two are ones that the industry is pretty familiar with. We have a spot mode and we have a dwell mode. Our spot mode enables very high resolution, up to 50 centimeters currently, using the largest available scene size for detailed monitoring. These are really good for object identification and detailed change detection. The ground resolution of this can go up to 50 centimeters, and this scene size can go up to 15 kilometers by 15 kilometers. Our dwell mode utilizes similar parameters as to our spot modes, but instead we dwell on one location longer than we would in a spot mode, sometimes up to 25 to 30 seconds. This dwell mode really helps extract critical information from single images. This also allows us to get a colorized sub-aperture image, which we'll talk about here in a second to show an example. And it also allows us to provide a video product, which stitches together those 25 to 30 seconds into a moving GIF or MP4 video that can be utilized by analysts to help look at what the images is showing them. The ground resolution of this can go up to 50 centimeters, and the scene size of this is at a 5 kilometer by 5 kilometer. Our phased array enables us to do two modes that I mentioned previously, strip mode and scan mode. Strip is a 30 by 50 kilometer imaging mode that can be extended in the along track up to 350 kilometers with a ground resolution of 3 meters. This imaging mode is perfect for detecting changes in the sea and on borders, natural disasters, illegal activities. Monitoring of coastal areas and ports are also very good use cases for this strip mode. Scan mode increases that size to 100 kilometers by 100 kilometers, and we can extend that also in the along track up to 840 kilometers. This mode is particularly effective for acquiring wide imaging modes and acquiring wide coverages. National security and maritime safety can benefit greatly from this type of imaging mode. Go ahead, Alexandra. Here's just some examples now of just the sizing and comparisons of these images. So on the right, you'll see all of our images overlaid onto a single page. You can see scan is the widest, which is the entire square. Strip is the 50 by 30 kilometer. And then as we go down, we get down into our spotlight extended area, which is a resolution of 1 meter at 15 kilometer by 15 kilometer. And then our spot and dwell and our spot find and dwell find. And coming soon is our dwell precise, which gets us to a 25 centimeter resolution. On the left here, you'll see that we actually have the ability to do some variable scene resolutions depending on the unique mission requirements. As I mentioned in the previous slide, strip and scan can be extended in the along track areas. And as you can see on this image here, we can extend a scan up to 840 kilometers. So that's 8.4 times the size of a normal scan, and we just keep that array on and imaging on the Earth. This is really useful for large swaths of images, such as or areas such as borders or ports that you're trying to monitor. Strip images can also go for a total and increase that up to that should be 350 kilometers in coverage. Go ahead, Alexander. So here's some sample imagery that we actually had taken last week with all of our imaging modes that we've talked about here, some of them with some variability on here. So we have a scan, we have a strip, we have a spot find, and we have a dwell find over a location that I think a lot of you are very familiar with, which is the Goddard Space Flight Center. So if we can continue on to the first image, Alexander, we're going to see a scan image over the Goddard Space Flight Center. The scan image has a resolution of 12 meters, so we will be able to see all of the nasty traffic that normally comes with this. But you'll see that The time there was taken on April 19th, and this image has actually been cropped to meet the slide size. This image actually does go wider in the north and south directions. Go ahead, Alexandra. The next we're going to see here is a strip image. So we've zoomed in now to a 30 by 50 kilometer resolution with a 30 by 50 kilometer coverage with a 3-meter resolution. Still over the same area with the Goddard Space Flight Center. You can now see a little bit more detail, a little bit better contrast as this imaging mode is a higher resolution over a smaller area. The next imaging mode that we'll see here is our 5 by 5 spot find. This image, go ahead, Alexandra. This imaging mode will have a 50 centimeter ground resolution with a 5 by 5 coverage on here. And you can make out very particular buildings, roads, and if you were to look even closer, you could see some vehicles on the ground as well. Some very clear returns here and very clear which building is which and the spacing of everything in this image. The last image, go ahead, Alexandra, is our dwell find. Our dwell find comes with this unique product which is being shown here, which is our CSI, our color sub aperture image, which we can go into greater detail in a little bit. This is also at a 50 centimeter resolution, but as you can see, the image is more clear. We've spent longer dwelling over this area, and we can also get unique returns off of these buildings due to categorizing the angle of return during the imaging mode. This can be really useful because, as you can see, man-made objects, due to their design and their build, have unique returns that come back to the satellite that actually allow even analysts to look at this image and say that's something that isn't nature. This can have large impact when looking at extremely forested areas or areas that everything is cluttered together. You can pick out really interesting and unique items in images with the use of our CSI. Go ahead, Alexander. So I'm going to hand this over now to our SAR expert, Dr. Tom Mitchell, who's going to delve a little bit more into SAR at ICEYE US and give a little bit of an overview into the science behind everything that we do.
Hi, thanks, Alva. So I'm Tom Mitchell. Alva just talked about our various imaging modes, the products that are available from those modes. I'm going to spend some time here highlighting another ICEYE capability, and that's our ground track repeat. So ICEYE US is currently in the process of moving satellites into this ground track repeat orbit, which is a coherent repeat pass orbit, with our goal being daily revisit with less than 500 meter ground track shift between collects. This will enable the collection and production of interferometric and change detection products. We have an example of the GTR stack that we collected over a volcano in Spain. Because these collections were taken from essentially the same geometry, we're able to pull out detailed information about changes off of the ground. So here in this example, we can monitor the changes of the lava returns over time from collect to collect. This will enable us to get an estimate of which parts of the lava flow may have hardened, which are still liquid and potentially flowing, and then areas that the lava has recently expanded into. So we plan on announcing hopefully soon that our GTR sensors are being able to be tasked, and we will build that capability out further as demand is needed. So the next few slides, I'm going to go over some use cases and examples of this GTR capability that we've collected previously. This example here is a great example of what you can do when you have an extended collection staring at the same point on the ground from the same geometry over a large period of time. So this movie should play, you see near daily collects extending of about a 3-month period. So what this enables you to do is to build up a pattern of a life of this collection. These are over the port of Rotterdam. The most obvious changes here you see are the various ships that are coming and going. This may allow you to extract information about the type of ships that tend to visit the port, which docks are used more often, which aren't used at all. Other changes you can see are the changes in the POL tank levels. You may be able to extract information about resources that are coming and going through this port. You can also see changes of the surface, the water surface returns. Maybe this can provide you some information about the wind or weather information for that particular day. And maybe you can extract some information about how that would affect the activity on the port, given those conditions. Go ahead, Alexander, next slide. So this next example, this is an example of a strip map GTR stack. So here we're looking at wide area, interested in wide area change, where we kind of substituted that finer look, higher resolution with wide area, coarser resolution. Here we're over a Brazilian rainforest looking for deforestation activity. So as this movie plays, you can see from day to day the canopy that is removed from this portion of the rainforest. So this really, would enable, researchers or groups who are looking for potential illegal activity to detect these deforestation activities using our ICEYE's GTR capability, which would be otherwise potentially hard to detect with conventional methods. Go ahead, next slide. This is an example of more, I guess, a classic amplitude change detection product. What these products are, they're comparing two images with each other. Returns that are shades of gray are returns that have not changed between the two images. Red would mean that an object was in the first image, but not the second, and blue, they're in the second, not the first. So what this enables you to do is to quickly look at an image pair and highlight the changes very quickly. Here we have we're looking at some sort of building, and you can see the vehicle activity, the departures and arrivals of the vehicles around that building. Go ahead, next slide. So those first three examples were kind of examples of our detected imagery, the magnitude image of SAR. Now we're going to get into more of the unique capability that SAR can provide. This example here is coherent change detection, CCD. What this is a measure of the complex correlation between the image pair that was collected. So area that is white represents fully correlated pixels. And then shades of gray, you start getting, as it decorrelates, you get shades of gray all the way down to black, where it's completely decorrelated, representing change in the scene. So here what we're looking for are ground disturbances. So this would not be a good product to use over urban environments. You're looking at disturbances on softer ground or agricultural type of activity. In this slide here, you can see in the background image, that's one of the detected images of this image stack. And you can't see any of the activity that is highlighted in the CCD callouts boxes. Those tracks are really only visible in that CCD product through the complex correlation. This would be a good product to use for extracting tracks, human activity, ground disturbances, or even animal movement or migration herding activity. Go ahead, next slide. So this is another product, the interferometric product that uses the phase, the complex nature of SAR data. So here, interferometrogram is essentially the phase difference between two coherent collects. And because of the way that those images were collected and registered together, the change in the phase represents essentially the height of the terrain. So one pair can give you an interferogram, and you can extract essentially a digital elevation model, a DEM, of the scene that you're looking at at that one point in time. If you collect stacks of these interferograms, you now can get an idea of how the ground is moving, how the subsidence or uprise in earthquakes or volcano zones. You can monitor infrastructure like dams or buildings to look for movement and potential failures of those. The example we have here on this slide is before and after of a volcano in Iceland. So comparing the interferograms from before and after this event, you can get a sense of how much the ground has shifted from that volcanic activity. Go ahead, next slide. Now I'll hand it back over to Alexandra, who will talk about how you can access our data.
Thanks, Tom. Appreciate that. So for now that you've learned so much about ICEYE US and all our various modes available, I'm going to go through and talk about the couple different ways of how you can access that data. So we have three main modes for this. That can be either through COST, which is our Customer Operations and Satellite Planning team, through our portal user interface, or through our API. So if you're using COST, we're going to say that that's going to be really ideal for customers that are interested in have needs that need to be responded to quickly. So COST is, they work 24/7, they're based in Irvine, and they're going to be there available to answer any of your questions that come in, whether that is for, is this available in the archive? Do we have a pass available for that tasking? So checking feasibility, or if you know what you want to collect already, then submitting that tasking and then getting that confirmation of when and where it will be collected. So that's going to be really great, again, for those customers that want to really leverage the expertise that our cost planners have, because they really know the limitations and really how to access and deliver the exact imagery and geometry that you're looking for. And then we would tell you quickly whether or not that is available. And also it's really great if you maybe don't have the time to play with messing with different parameters and want to just review and say yes or no to the feasibility study. The next option I want to talk about is Portal. So Portal is our web user interface. This is one of our newer options, and this is going to be a way for customers that are perhaps a little more hands-on, customers that want to utilize the portal to see if there is a pass available over their AOI of interest, over their date and time, and will it be delivered when they need it, and then submit the tasking right then and there. Or perhaps you just want to see what is available, what is in the archive, what can we have, what do we already have that meets your needs. You can use Portal. That's going to be great for those customers that really enjoy that hands-on experience. And then our API, our last option, that is for computer to computer. It's going to be great for those who really want to leverage automation. So if you know that you have the same area you want to be collected at a repeat basis or a certain cadence, we would definitely guide you to the API to do that as well. API can be used for archive it also. So it's how you configure your side of your API to query and ping ours. And then with the API as well, you are going to get a quick response shortly after whether or not that tasking was available to be collected. And then you also be notified when that is also delivered as well. So for delivery wise, it's not mentioned on here, but we have a couple different options. So we tend to use SFTP as well as our S3 buckets, so that can be replication. And really, we're going to work with you and see what works for your needs to help your workflow, what makes the most sense. Well, with that kind of covers our three main ways. You've gone through all our different modes with Alva, as well as some really good ways to kind of deep dive into how to use our those phenomenologies with Dr. Tom Mitchell. And that now we can turn it over to back to you, Jennifer.
Okay, perfect. Thank you so much, Alexandra. So at this point, what we're going to do is I'm going to open the final optional polls. And we really very much appreciate your feedback on these, by the way. And then we're going to, I'm going to just check really quickly in the chat to see whether or not there were any questions posed there. And then I'm going to transition, I don't see any, transition directly to the Q&A. All right, so bear with me for a moment here, if you would. Okay, hopefully everybody can hear me okay. The first question is, let me get the one that was not responded to. Let's see. All right, and it could be that if I scroll a bit further, someone has responded to this as well. But here's the second question. Here's the first question. Does ICEYE US plan or already have in place some sort of background observation scenario? If so, what drives this plan, and can you share any of this?
I can take that one, Alexandra. We do have, ICEYE does utilize a background observation tasking ability where we can place an image at a lower priority to acquire that image if it's not a time critical image. I will say that that is subject to whatever has been agreed upon in the CSDA contracts, but we do have that as a capability internally where we can place an image at a lower priority and let that sit in the system, be able to do that.
Okay, perfect. Thank you so much, Alva. And so the next question is, do any of these products provide images of normalized backscatter cross-section, or is the image intensity simply a relative intensity arbitrarily scaled, say, to enhance contrast?
Yeah, I can answer that. So all of our satellites are calibrated. So we provide a calibration factor in the metadata that will convert from the pixel value of the image to a radar cross-section value.
Okay, thanks so much. All right, here, let me get back to the Q&A. Okay, there was a question that was responded to, but since the response was specific to that, was sent directly to the individual, I think everyone could benefit from the response. I'm going to go ahead and read the question and also the response aloud and then move on to the next. The question was, what is the constellation orbital inclinations and equator crossing times? And the response was, hi, ICEYE currently operates all of its assets in SSO with various equator crossing times throughout a 24-hour period, depending on the specific asset. ICEYE also operates 2 assets in mid-inclination orbit at 45 degrees. All right, now let me swing down to the next one that has not been responded to yet. Is there an ice thickness data product over a large lakes?
I can also take that one. We currently don't have a data product for ice thickness. The data can be exploited by the end user to fit whatever needs they utilize. Tom or Kyle, I guess I would defer to you if that data, if our VV polarization would be useful in a situation like that, but we do not provide a information product specifically about ice thickness.
Well, thanks so much, Alva. Okay, and moving on to the next question here. Are there any limitations on the types of products that can be accessed through the CSDA? So Dana, this is probably one for you.
I can also chime in. So this is Alexandra, looking for this slide for. Really, what you're not going to see on the current contract right now is anything from our newer generation satellites, but we do hope to submit those for evaluation so that it can be available on future CSDA orders. So basically, we're speaking to no dwell fine, such like that.
Yeah, Alexander, let me just make one quick caveat to that too. First, dwell precise is the mode that we currently don't offer on the CSDA, which is our 25, but dwell fine we do, which is our 50 centimeter. Our newer generation satellites are capable of taking all imaging modes that are they're backwards compatible, is a good way to put it. So our newer generations can still be utilized on the CSDA contracts, but it's more of a mode dependent thing that we're working through with current licensing things to ensure that we can image 25 centimeter products. But once that is available, we will work to get that available to the end users through the CSDA contract.
Okay, thank you so much, Alva. Appreciate that. Let me see whether or not there are additional questions here. Just looking to see if I have I see something in the chat. Just bear with me for one moment here. Okay, is terrain correction performed?
Can you say that one again?
Oh, okay, good. I'm glad you can hear me.
Sorry, Jennifer, could you say the question again, please?
Yes, so I'm not sure if there is anything else that this particular webinar participant would like to add, but the question is terrain correction performed?
Tom or Kyle, do you guys want to take one of those or take?
Yeah, I guess I would need more information what they're asking, in particular what they're about. But I mean, we do an autofocus for our imagery, which would help account for some of that, I guess. But as far as specific terrain, back projecting to terrain, no, we don't do that. We back project to a plane. But if something else you're asking about, I guess we would need more information.
Okay, thanks so much, Tom. And if the webinar participant would like to add any additional details or context, please feel free to do that, and then I can revisit the question in a few minutes. So at this point, I am just scanning the Q&A, and I'm not seeing any additional questions that were not already answered within the Q&A, either with a typed response or a verbal response. However, a new question has just come in. Are there any open data sets available?
Yes, there is. We have, and I can post the link as a reply to that question. We do have example images on our website that are free to download, and they have full resolution and full data sets associated with those. And I will post that as the answer to that question in the Q&A.
That sounds great. Appreciate that very much. Okay, so while we're waiting to see whether or not there are any additional questions from our webinar participants, just really quickly, I wanted to let everyone know that yes, this afternoon's event was recorded, and I do intend to post the, the recording, upload that to our NASA Earth Data YouTube channel. There's a CSDA specific playlist on that channel. I can place that playlist link in the chat in just a few minutes. And then finally, I will send a link to the recording as well as to the presentation slide decks to everybody within a couple of days of completion here. All right, and I have muted all of the panelists at this point. We're getting a little bit of feedback, so I hope that's a little bit better. All right, just let me swing back down to the Q&A. Looking to see whether or not, thanks for placing the link in the chat, Alva. Okay, so the next question is, could ICEYE provide daily observations of a sea ice drift buoy in the Arctic to track a moving buoy target?
I can also answer that one. I guess I would also need to have a little more information on that, but we have a very high revisit, especially when coming into the poles in the Arctic, sometimes sub 1 hour revisit times. And as long as the parameters required weren't extremely restrictive, such as you need specific look angles or specific pass directions, there shouldn't be a reason why we wouldn't be able to get constant coverage over that location utilizing different modes. Like I had mentioned previously as well, our dwell modes do utilize that 25 to 30 second duration. So depending on how fast that buoy is moving, we could potentially see it moving across that image. And then you could continuously take images of that area to see where that buoy has moved to.
Okay, thank you again, Alva. So our next question here is, will low latency data be available for disaster response?
Yeah, low latency data is definitely available. We have right now our standard, and Alexander, you can correct me if I'm wrong here on the specific for CSDA, but our SLA for all imaging products is below 8 hours. Our average delivery rate is 4 hours, but anywhere up to 8 hours is allowed contractually. Right now, there's no additional ability through the CISDA contract to get additional quick disaster or quick delivery, but everything will be delivered within 8 hours. Like I said, with an average of about 4 to 5 hours.
Okay, excellent. Thank you. So the next question is, are there free tools and packages to extract metadata and process the SAR images?
I can respond here. So a lot of what we use is SARPy, which is an NGA SAR Python library that can read in our SICIDs and our SIDs. It also can read in the ICEYE reader, which reads in our SLC H5 mode. So all of that will extract the metadata, and you could view the image there too. I think there is some snap capability to read in our data. However, I'm not familiar with the with snap, and I've never used it, so I can't speak to what's available in there.
Well, thank you, Tom. Really appreciate your response there. All right, with that, let's move on to the next question, which is, I would like the task collections which coincide with existing NASA satellites. I know the NASA satellite orbits, but I am not sure how to discover what ICEYE collects would coincide in time and location. How would one do this?
Yeah, I can take that question. So how our current API functions is you ask for a time window with certain parameters, and those parameters can be imaging angles, those parameters can be time windows. Those time windows can be as short as 20 minutes up to 14 days. Same thing with past directions and that design. In the future, we're going to allow the ability for you to see what opportunities exist within a time window before tasking, so you know what would be achieved. But right now, how our API functions is we accept a task for a given time window with parameters if that task exists, and then we tell you what time that image has been placed at. Now, there is no guarantee that that image won't shift within your accepted time window. So if you did give a time window of 12 hours and we say that your image will be acquired 2 hours in, there is no guarantee that that image won't shift to another time within 12 hours if our system reshuffles. But currently, you will know the time once the image has been accepted, but in the future, we're going to allow the ability for you to see the opportunities within a given time window. But the system will always respect the parameters given, such as time window, the incidence angles, and all of those parameters, and will never deviate from outside those parameters. So if you do know the NASA locations and you want something that coincides with that, you can give a very restricted task request. It may not be fulfilled because we may not have the ability to fulfill a very restricted task request, but that functionality does exist, and we'll be improving that in the future.
Okay, thank you, Alva. The next question is, can ICEYE provide oil spill thickness products?
We don't have an oil spill thickness product that we give as an actual product that we sell, but our SAR data can be exploited to use and work with to meet your mission needs, but we don't provide that as an actual end product.
Okay, excellent again. As a follow-up to the earlier question, building on the previous question, since other organizations often task ICEYE in response to disaster incidents, would that data also be available through CSDA? Will we be able to see whether task orders have been submitted already to avoid redundant tasking?
That may be a question more for Alexandra or Dana, but I will comment that we never want to have redundant tasking. We never want to have you collect two images when one would have done the trick. But I don't know what will be shareable contractually through CSDA as a in respect to other agencies. Alexandra, Dana, I don't know if you have the answer to that one.
We don't have a requirement to share and deconflict. I know the hope is that we are planning to work deeply with CSDA with the API in order to help deconflict, so that at least from CSDA, tasking is centralized, so that way within and through that contract it is not redundant and it is optimized. That's good feedback about that. That's a factor thinking about other agencies and multitasking.
Thank you, Alexandra. All right, so the next question is, can I programmatically submit thousands of queries to discover overflight or tasking opportunities?
Yes, we don't have a rate limit on the requests into the system. Our system doesn't have a measure to prevent that. I would say I would attempt to avoid that just because thousands of requests won't give you more insight into the system. What would give you more insight, because we just don't have thousands of opportunities in a single time window, so a lot of those would just end up being redundant. I would suggest that instead you would request a time window and see what opportunity comes back as accepted, and then you can see what that time that is. That's what I would do in the meantime. Once we have the ability for CSDA to ping our opportunities, you will be able to just see what opportunities exist in a time window. So instead of querying the system thousands of times, which really won't get you any additional data, or requesting thousands of tasks, which won't get you any additional data, the more lucrative route is to utilize our opportunities endpoint, which will be available within the next month or two.
Okay, outstanding. Let's move to our next question here. What software is used to produce interferograms with ICEYE data?
Currently, we use SAR Pros to process all of our coherent collects. So that does the registration, and it will provide the change maps, so the CCDs and the interferograms.
Thank you so much, Tom. All right, here, let me just go ahead and take another look to see. Don't think I have missed any questions. Oh, okay. There's a new question. Let me go ahead and get to this. I may have missed it in the presentation. Could the panelists clarify whether all ICEYE assets, especially the new generation, are X-band VV single polarization?
Yes, I can confirm that. All are X-band with single VV polarization. In the generations beyond generation 4, we do want to look at including maybe additional polarizations as well. But currently, with the current generations, yes, they are VV and X-band.
All right. All right, thanks again. All right, so the next question is, what are the equator crossing times or range for the sun synchronous systems?
The equator crossing times really vary across the day, just because of how often or how many assets we have positioned. But they can range from our repeats are typically anywhere from 18 to 21 days, except for our ground track repeats, which are daily. But there is no specific time that we have for equator crossings for all of our assets. They vary across the day, just due to the size of the fleet. An orbit for us takes about generally 90-ish minutes, give or take 5 to 10 minutes on each side.
All right, well, we appreciate your response. Looking to see if there are any additional questions. I don't think we have missed any questions. So if there are no additional questions, what we'll do at this point is we will leave the virtual meeting space opened, but log off from the audio component. So if there is a question that you think of, please feel free to pose that question in the Q&A panel. I also wanted to say that we appreciate all of your feedback for the optional polls, both at the beginning of the webinar and also at the end. And I'd like to thank all of our panelists from ICEYE US, as well as our speakers, and thank also Dana Ostrenga and my backup host, Joseph Smith, for your assistance today. All right, everybody, take care. We are going to log off from the audio component, but I will stay online and leave the virtual meeting space open. All right, take care now. Goodbye, everybody.